Welcome to the course of Artificial Intelligence and Machine Learning. The course code is 22CS106. This is an integrated course having 3 credits for the theory and the 1 credit for the practical or the laboratory. Today, I would like to discuss about the artificial neural network ANN. But before starting the session, I would like to introduce myself. Myself, Dr. Shomik Poddar, Assistant Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana, India. For any further communication, please watch my mail that is somik.poddar@sru.edu.in. So today's session titles are Introduction, that is the definition of the artificial neural network, its respective structure and the mechanistic operation. Then I will highlight the perceptron model, and finally I will discuss the different types and the bias function or activation functions needed for the artificial neural network. So what is artificial neural network? This artificial neural network is a mimicry of the biological neural network. So from our school level education, we know that the biological neural network is simply a construction of the 3 elements. First one is the dendron that accepts the stimulations or the input signals from the rest of the body or the outer of this outer of the neural network. Then the signal will be processed through the neuron or the cell, and finally it goes to the axons that we can be propagated to the another neuron via the synaptic fluid. The synapse is basically the interconnection between the 2 neurons. So, being inspired by this human brain, the scientists have developed this artificial neural network for better classification and prediction for the large number or large dimensional data. This is the structure of the biological neural network. Here we have seen the different components of the BNN. First one is the dendrite that can accept the inputs, that can accept the signals from the rest of our body. And these signals or the stimuli will be propagated through the cell nucleus and the axon, and finally it will propagate it to the another neuron via synapse. So this structure can be mimicry into the development or the formulation of the ANN structure. So being inspired by the dendron, I can put the input signals, which are I have shown you inputs 1 to input in. Then there are nodes, that is x1 to xn, which can accept the input signals. The input signals will be weighted via some weight function w1 to wn. These weighted inputs will be now propagated through the neuron, and finally it goes to the output. In the neuron, there is some activation functions. That means it will activate the input signals to produce the desired output. Or better, I can say the activation function is some nonlinear mathematical functions that can stimulate the neuron to produce the desired output. Now going to the similarity or the relation between the biological neural network and the artificial neural network. Already stated that ANN is a mimicry of the BNN structure. So the BNN components has some sort of similarity with the components of the ANN. First, we have looked upon into the similarities. First, the dendrites of the BNN will be resemble with the inputs for the ANN structure. The cell nucleus will be behave as a nodes. The synapse will behave as weights, and the axons will behave as the output. So by using this structure, we can formulate the output and easily classify between the huge dimension, large dimensional data, and we can get the desired solution, quick desired solution with the effectiveness than the traditional ML models. This is the architecture of an artificial neural network, where I have shown you that the yellow color box represents the input layer. The input layer means it is an formulated layer where the input nodes are present. The input nodes are the point that will accept the input signals. Now, input signal means these are the historical data after feature extraction. So these data will be captured by the input nodes. Then they will be propagated to our first layer, that is a sky colored layer, whose name is hidden layer 1, because these layers cannot be accessed by the users. Then another layer is present, that is called hidden layer 2 for better classification. Finally, the hidden layer 2 is connected to the output layer. The output layer nodes will be definitely smaller than the input nodes, because from the large inputs we have to decide our desired output. That is, basically we are doing the binary output, that is the high or low, yes or no, true or false, whatever may be. So this is called the classification. So that's why the output nodes will be lesser than the input nodes. Now, in this case, we have seen that every outputs from the input nodes are connected with each and every nodes in the hidden layers. So thus, as the input layer consists of the 4 input nodes, and each input node is being connected with the 3 nodes of the hidden layer 1, hence the total number of connections for the hidden layer input section is 12. Similarly, the output section of the hidden layer 1 will be connected with hidden layer 2 via same formula. That means each hidden layer 1 nodes are connected with is connected with the each hidden layer 2 nodes. So therefore, 3 cross 4, that is 12. These 12 combinations will be further reduced to this 1, 2, 3, 4, 5, 6, means 4 into, that is 8 connections. So by this way, we can easily predict. So that means very simple connectivity will make very complex and very means what I can say that it will create some mesh-like structure. So from mesh-like structure, we can get the different numerous combinations. So from numerous combinations, it will be very much helpful to optimize my decision or optimize my prediction of the classification. That is the essence of the artificial neural network, which is absent in our traditional machine learning models. Now the formula by which we can calculate the outputs, that is the summation of Wi cross Xi plus B. What is Wi? Wi is a respective weight function for a particular node. If the node 1 is considered, that is the W1 will be the weight. Suppose this is your input node 1, this is input node 2, 3, 4, and this is hidden layer 1, 2, 3. So the first node is connected with the first node of the hidden layer 1. So that's why it becomes a W1 or W11. Similarly, first node is connected to the hidden layer 1 second node, so it becomes W12. So better I can write it as a Wij, where it will be started from I equals to 1 to n and j equals to 1 to m. M is basically the total number of nodes in the hidden layers. Into Xi, similarly, Xi will be the respective input signals. I am stating signals, or I can state input data plus B. B is called the bias function. So bias function means it will fire the neuron so that it can easily produce the output. You cannot use a bias. Many times we cannot use many models have bias, but bias is necessary for proper operation of the artificial neural network. Now, advantages of the ANN. ANN can process the data by parallel mode. It can store the data for the entire network. It has a capability with the incomplete knowledge, because incomplete knowledge means the incomplete data. If I have incomplete data, but by using the multiple layers or the multiple hidden layers, we can easily create the many number of combinations, so from which we can produce the less amount of the loss and provide the better prediction. Having a memory distribution, this is because of the feedback connection I will discuss. Having fault tolerance, it also be useful when the feedback ANN will be implemented. But the disadvantages, first of all, the processing speed is quite low, because there are the signal propagation takes place between the multiple hidden layers. So that will be create some sort of latency or the delay. Unrecognized behavior of the network. That means whenever any unrecognized behavior is detected, so that means that ANN will not perform effectively. Hardware dependence, because artificial neural network needs the processors with the parallel processing speed. Difficulty of showing the issue to the network, and the duration of the network is unknown. Means when the operation will be completed, that will be very difficult to predict because of the presence of numerous hidden layers. Now, how do artificial neural networks work? As already stated previously, each input signals coming from the respective nodes will be multiplied by its respective weighted function and then go to the hidden layers. After that, the same value will be again further multiplied with another weight function to go for to the output nodes. Thus, we can predict the output. So suppose WX1 is the input node, input signal coming to the node 1, and it is the total number of hidden layer nodes will be J. So I can write the first one, the first connection has the weight will be wij, where I equals to 1, j equals to 1. Similarly, this will be 1, 2, this will be W13, this will be W12, this will be W13, this will be W14, and so on. Then the same signal will be again further cross connection between the hidden layer and the output nodes. That will be again defined by the wij. So thus there will be a large number of combinations from which we can develop different output y1 to y3. Finally, all the weighted inputs are summarized inside the computing unit. Bias has the same input. Basically, the bias is called the input when the no external inputs are present. So from the equations, as already I have shown you, that the wi star xi plus b. So when this xi will be absent, automatically the output will be b. That means whenever the system is totally off, not accepting any signal, but still it will produce some sort of output. So it will not the unproductive. So that output is called the weight that bias function. Now coming to the perceptron. Perceptron is basically the single layer artificial neural network. So I cannot state that the perceptron is a neural network, but I can say that perceptron is a unit or the model of the ANN. So ANN is basically the summation of perceptron. That's why ANN is also called the multi-layer perceptron, because the perceptron has only a single hidden layer. The first artificial neuron was produced in 1943 by the neurophysiologist Warren McCulloch and the logician Walter Pitts. After that, the perceptrons was developed in the 1950s and the 1960s by the scientist Frank Rosenblatt. So this is the pictorial presentation of the perceptron. The perceptron has the suppose I have taken the three inputs, x1, x2, x3. So each having the different or the unique weight functions. x1 has a weight function w1, x2 has w2, x3 has w3. So their product will go to the V, that is the neuron. The neuron will be produce the output Y. So a Y can be written as some function of V. So this function is called the activation function. Now how the output will be produced? Basically the output is determined by some threshold. So whenever we are developing the perceptron, first we have to set some threshold depending on our input data. So for the 0 and 1, if the input data will be 0 and 1, the output will be the 0 and 1. So if wijxj summation will be less than threshold, then the neuron will produce the 0. If summation wjxj will be greater than threshold, it will produce the output 1. Now coming to the section of the category of the ANN. ANN is basically categorized into the two classes. One is the feedback artificial neural network and another one is the feed forward. So far we have studied the feed forward. What is feed forward? Just looking into this is a very simple architecture where the signals are coming to the input layer or the data, pre-processed data and the feature extracted data are coming to the input layer. The input layer will immediately provide some weight function onto the inputs. weighted inputs are then going to the hidden layer, and finally they will be processed. Means in the hidden layer, basically the activation function is imposed as well as the bias value. So hidden layer is basically responsible for providing the activation function. Now the activated and the further weighted signals are going to the output layer, and we will get the our desired outputs. But in the feed forward, we have basically, I have shown you the typical model where the two outputs are present. The binary classification I have done. But in this, so this network is called the feed forward network. But the problem in this network that whatever the input I have said, it will directly produce the output, but no review. Means seriously, if I am getting the outputs, so are the inputs same, means our desired input. Means I want to say that suppose I am getting some classified outputs. Now my question is that are the classified outputs are seriously the outcome of the inputs whatever I have applied, or something else, that is means some noises also produce the same output. So that creates a lots of confusion in the feed forward. So that's why we are developing the another AINN which is more practicable and produce the more authenticity. That is called the feedback ANN. In the feedback ANN, the output nodes are basically behave as the inputs, and the input nodes are behaves as the output. And in this case, output nodes are when it will be considered, basically the path will be just opposite. If I am showing you that the outputs are again provide some weighted functions, and then it is going to the hidden layer, and finally the same operation will be taking place. Finally, we will see whether the actual inputs we have provided are seriously they are restoring or not. So there is one important parameter. It's called the loss function. Loss function means if the inputs whichever we have applied and inputs whichever we have got are serious, if they are not similar, then some loss functions will be present. Now coming to the activation function. Activation function is basically the function to get the output of the node. Activation function is also a nonlinear function because activation function provides the many combinations. So many combinations means there are a randomization. So in that case, some nonlinearity will be embedded. So this nonlinearity has a very significant contribution. We will discuss in our next slides. But before going to the next slides, I would like to introduce the basic thing for the activation function. Here, after the bias value is provided, the activation function is now incorporated. So y equals to function of W transpose X plus B, where W transpose is a column and row exchange of the weight function, which is represented matrix, and S is also the one matrix representing the inputs variable, and B is the bias value. So finally we will get the output. So this if is one of the interesting parameter that will decide how the outputs will be calculated or formulated. Purpose of the activation function, basically activation function is, if you see the graph, then it will be very easily understood. It's a pictorial presentation. Suppose I have taken some inputs and multiply by the neurons weight. automatically the small inputs will become the enlarged. After that, I have produced some bias, a plus sign, means I have added something. The bias value will produce some fair result, that is the blue box. That is that means our desired result. Again, the result, if you see that when the after adding the bias, I am also trying to correlate the output with the input or the weighted input. So this correlation is nothing but the activation function. Activation function take the output and transmit to the next layer of the neurons. It will facilitate. Activation function will be two types. One is linear, another is the non-linear. Linear means that is when the output is written as W transpose X plus B, that means it is called the linear. Means whatever the inputs are, if whatever the gradient of the inputs, the same gradient will be followed in the outputs. Means if the inputs are increasing, then the output will also increase, like so and so on. But non-linear means some ReLU, 10H, etc. Where I will show you that I cannot predict the exact value of the output. So linear function already I had shown you, but still I have elucidated y equals to wx plus b. So it is a simple mathematical equation of the straight line y equals to mx plus b. M or the weights is basically the slope, and x is the input signal, b is the bias. So that's why the red color line represents this linear function. After, if I am taking the derivative, then this is a dy dx, it becomes a straight line. So this derivative of the linear function, what is the significance of the derivative? The significance of the derivative means, that means how correctly or how precisely the the function will operate. That's why we are developing the derivative. So derivative is fixed, so that means it has a fixed decision power, that if the inputs are increasing, automatically the outputs will be increased. If the inputs will be negative, output will also be negative. Next one is a binary step. So here I have eliminated the linearity. Rather, I am fixing the two output, that is the high or low, 1 or 0. So whatever may be the variations of the data set and also the weight function. So, but I can fix the output in between two discrete levels, 1 and 0. But in that case, some threshold value will be set. So if wx plus b greater than equals to 0, then the output will be 1, otherwise 0. So the activation function derivative will also be 0. That means this binary step activation function, as it has the two fixed level, so we cannot go for any other small levels. It will, whatever may be the inputs, it will produce only two fixed outputs. In coming to the non-linear function, it is the first one is the sigmoid or the logistic activation. It basically, the function is fx equals to 1 by 1 plus e to the power minus x. So the sigmoid function is looking like this. So it is a non-linear, but the value will be 1 and 0. But from the switching from 1 and 0 is basically it is a non-linear link, and its derivative will be fx into 1 minus of fx. Then coming to the 10H activation function, it is used for the deep learning, 10H image processing also. So 10H activation function is basically levels, 1 and -1, but it resembles with the sigmoid function. ReLU activation means it is a mixture of linear as well a linear function, but it is a rectified linear. That means for the data which are positive, then we can we can predict the output linearly, but whenever the data is negated or the negative data, automatically it will produce the zero output, whatever may be. So that's what is called the ReLU. Next one is the leaky ReLU. Leaky ReLU means it is somehow flexible, not very stringent, just like the ReLU function. So whenever the input data will be negative or negations are present, the model will not produce exactly zero, but it will predict something lower value um, compared to the value when the input data will be positive. So by discussing these different activation functions, we can easily understand that when we will apply the proper activation functions to produce the effective or the optimized output. So that's all. Thank you very much for listening my lecture.